Hi everybody, welcome to the first video on scientific method review. I hope you're doing well, and I hope you enjoy this little picture here. Thank you to everyone that's already sent in different suggestions. I just wanted to say that I am limited with what I can show, what is appropriate. I have to follow strict guidelines. So if I can't show yours, I will let you know. Please don't feel bad. The goal is really just to make sure that there's something at the beginning of every video that will make everyone smile. So with that, let's get started for today. Okay, a few comments before we start with scientific method. The first one is I wanted to talk about notes. So how do I expect you to kind of follow along with the online learning? So there's a few different options. The first one, if you do have a printer, I know a lot of you don't, that's okay. One option would be to print the completed notes on Google Classroom and highlight with me as I go through them. Another option would be to make a copy of the completed notes on Google Classroom into your Google Drive. The next one would be to take your own notes, whether that's just on a piece of paper or maybe you make a new Google Doc in your Google Drive. And the last option would be to just follow along. If you just want to listen to the video and that's the kind of learner you are and it works for you, that's great. So whatever method you choose, please try to stay organized. It's going to be really a great skill to help you manage your work with the online learning. So even if that means you're just continuing to use your binder or you're organizing your Google Drive, that's really going to help. And the last thing is pausing the video. So that's something I'm going to be asking you guys to do for the rest of the year. I'm going to ask questions in the video and give you a chance to pause the video. So that gives you really as much time as you want to think about what your answer is and to interact with the video. Okay. Scientific method review. The scientific method is a series of steps that are followed when we perform an experiment. Today in this video, we are only going to focus on question problem, research, identify your variables, and hypothesis. Next week, we are going to focus on materials, procedure, observation results, analysis, conclusion, and future research. So what I'd like you to do now is to focus on the first four. You are going to pause the video and try to describe in your own words what happens in each of the first four steps of the scientific method. Okay, so let's look at these four steps together. The first step is question problem. So based on an observation, you start to question something. So I've come up with an example for you guys here. Let's say that this is your sidewalk right here. 1 second. Ta-da, right here. And you see that there's a flower that's growing really close that isn't really doing that well. And there's another flower that's a little bit further away that's doing great. And you think to yourself, I put a lot of salt on my sidewalk in the wintertime to melt the ice. So based on everything I just described, based on what I'm observing here, here's my question. I wonder how the amount of salt affects the growth of a plant. And I can turn that into a testable question, which is essentially just a question that is more specific for an experiment by doing this. So I'll let you guys read it. It says, what is the effect of the concentration of salt on the growth of a tomato plant? So what's great about a testable question is that it has a very similar format every time, similar structure. So we always say, what is the effect of something on something? So here what we've done is we've been more specific by saying concentration of salt and instead of amount of salt. Okay, and the reason why I did that is because now I can take a certain amount of salt, dissolve it into water, and water the plant with it. And I've also been more specific by saying, yes, it's the growth of a plant, but it's a tomato plant. So this testable question is really going to allow me to design an experiment really easily. All right, so step number 2 is research. And this is the step where essentially you complete some research to learn more about your topic. And I won't talk too much about this, but I do want to talk about what is a credible source. What is a source that is trustworthy? So the first one I found is from University of California, and that's a pretty credible source for me. I can really trust that source. And if you wanted to pause the video and read through it, you can. The main points for me in here is that just having salts is not in itself immediately harmful. It's when they reach a concentration too high. So that really supports my testable question from before. Then it says, as salt concentration rises, then the water does not flow as freely into the cells. So here, I know that he's talking about osmosis. And that gives me a better understanding of what's going on here. Next source that I found from doing some research was from the University of Vermont. And I don't want you guys to think you have to only find sources from universities, but this one was also really helpful for me because he talked about how when salt dissolves, we get chlorine ions that can accumulate into toxic levels that can actually hurt the leaves, scorch the leaves. So all this info is going to really help me design my experiment and also help me when I write my hypothesis later on. Okay, time for variables. So what I'm going to ask you guys to do is to first give me a definition. So you're going to be pausing the video and I want you to define in your own words manipulated variable, responding variable, and controlled variable. All right, first, manipulated variable. The manipulated variable is the one element that you purposefully change. You are going to be changing this and seeing how does it affect the responding variable. So responding variable, the one element that is observed and measured because it changes in response to the manipulated. And last but not least, definition for controlled variable. It's many elements. So there's often many controlled variables that must stay constant or the same throughout the experiment, otherwise they'll affect the results. Okay, so now what I'd like you to do is I'd like you to consider our testable question. And I'd like you to try to identify the variables for that testable question. So what is the effect of the concentration of salt on the growth of a tomato plant? So try to think about what you would do for your experiment and identify manipulated variable, responding variable, controlled variable. Okay, pause the video. I'll see you in a second. Okay, so here's what I have. For manipulated variable, I said the concentration of salt dissolved in water. And this is kind of what I decided to do. I'm going to have 3 plants. The first one is going to be my control, and this is really important. In an experiment, you need to have at least one trial where you don't put the manipulated variable. So you see here, this one has no salt. Okay, so what you're going to do later is you're going to compare your results back to the control. This is going to allow you to really conclude on the effect of salt. All right, next is responding variable. What I said was growth of the plant. And what I decided to do is actually make it more specific by talking about qualitative data and quantitative data. So qualitative data is the quality, okay? So it is, for example, health of the leaves, colors of the stem. It's things that you can determine just with your senses and there are no numbers. Then you have quantity in quantitative data, and it's going to be your numbers. So we have, for example, height of the plant, numbers of the leaves. But really, if you wrote growth of the plant, it's perfect. Okay, that is what we are going to be measuring and we're going to be observing during this experiment because we expect it to change when we change the concentration of salt. All right, last but not least, controlled variables. So here are some of the ones that I identified. One that I'll take, for example, is same amount of sun right here. Okay, the reason why we need to control this one is because if we have the plants in different areas where they get different amounts of sun, now we have the sun and the salt affecting the height or the growth. So we want to make sure that it is only our manipulated variable. We only want the concentration of salt to change the growth. So we've got to make sure that the sun, the amount of sun, stays the same. Okay, so before I continue on with the hypothesis, which is the last part of this video, I just wanted to take a second and say if there's at any point during this video or any video for the rest of the year that you feel lost, pause the video, rewind, and watch it again. And that's really the beauty of these online videos. It allows you to go at your own pace. So feel free at any time to stop me, go back, watch it again, and if you still have questions, you can always comment on the Google Classroom or send me an email. Okay, time for the hypothesis. So a hypothesis is a prediction about what you think is going to happen to the responding variable when you change the manipulated variable. Okay? Your prediction needs to be based on scientific principles and ideas. And this right here is actually what we got when we did our research at the beginning. It is okay if it is wrong in the end. Okay, but we just want to make a prediction. So here's the format. If I make a change to the manipulated variable, then I'm going to see a change in the responding variable because I know something from my research. So what I'm going to ask you to do is you are going to remind yourself what the manipulated variable was, what the responding variable was, and use the format that I have right here. Use the format to write out a hypothesis. Okay, then we're going to compare. Okay, so pause the video and use the format to write out a hypothesis. Okay, so what I'm going to ask you guys to do now is to use the format here and the work we've done to identify variables just before step 4 to write out a hypothesis. We will then move this box and compare with what I have here. So pause the video and do this task, please. Okay, time to see the hypothesis here. So the first thing that I always check is that I have the if, then, and because. This allows me to split up my hypothesis into 3 parts. First was the manipulated variable. So if I water the tomato plants with different concentrations of salt, so here I'm changing the manipulated variable, then my prediction is that the tomato plant watered with the most salt, so the highest concentration of salt, will be the most negatively affected in terms of growth. So I haven't been specific here because if you remember, I wanted to talk about qualitative and quantitative data. So the quality of the plant and also really how tall, how many leaves, that kind of thing. So I've just said that the plant that has the most amount of salt applied will have the most negative effects in terms of growth. Now the last part is where I use my research that I've done. And I say because the concentration of salt, the concentration of salt in the soil prevents water absorption. That was the osmosis research that I got. And chlorine ions can negatively affect the leaves. So it makes sense that the more salt you have, the more negative effects you have. And there you have it. There's my hypothesis. So thank you guys so much for watching this video. I hope it was a really clear explanation of the first 4 steps of the scientific method. Please let me know if there's anything you think I can do better to explain these concepts better to you in an online way. And again, if you have any questions, don't hesitate to send me an email or to comment on our Google Classroom. Please check the Google Classroom for the assignment that will give you practice on identifying variables and writing hypotheses. Thank you guys. Take care. Bye-bye.